da, da, da. With the next one, guaranteed we're going to use all these questions that we have looked at. Not all of them, but definitely a good chunk. There's a reason why the question with the highest difficulty is at the end. It's because it's the one that needs you to be creative. Are you going to use all the previous questions? Are you going to use some of them? Because that's literally what you need to do most of the time. And let me just also copy the sketch here. So you can also see we've copied this sketch twice now. It's up here, it's here also, and we're bringing it down here. So obviously it's for convenience, yes, but then it's literally because if you don't have your sketch with you often and you don't refer to it often, you're just wasting your time. Yeah. So it sounds weird, but I think everyone does refer to the sketch as often as they can, but that's us thinking for other people, but which is wrong anyway. So why? Let's just do what we need to do. So it says here, determine the coordinates of M, okay, which is the midpoint of AC. So 3 marks, like guaranteed, you know? Yeah. So you can see I'm kind of like repeating myself over and over and over, going to re-saying things like, yeah, you see why I pass papers and blah, 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 blah. There's a reason for that. I'm trying to give the idea that there's value in you knowing what's free and what you need to work for. Because people tend to not do the small things like this, and then they end up working for 3 marks. You see, no one will ever work for something that's free. It makes no sense. But then when you don't know what's free, then you end up working for it. Then you think the world is unfair. No, you see, it's just lack of accountability or whatever. So T is a 2, and then P is a -5. There we go. You know, this is one of those questions where you're just cruising, you know, cruising nicely, you know, like Julius Malema. But then the midpoint, it's simple, it's straightforward. But then the issue now is you want to realize why they're giving you this simple and straightforward questions. They're giving you these simple and straightforward questions because they know you're gonna need to go back to them, guaranteed. And we'll even see it just soon after this. Let's see here. AC. Let's see. The midpoint is this plus that, -5 plus 2, and then 3 plus the 5. And then we have here -5 plus 2, right, is what? -3/2. Yeah. This is 8/2, which is like a 4. Perfect. And then again, we want to fact check our answer. So fact checking this, yeah. Even though this was the point made, it's not so out of the line. It's the X value is like somewhere there, because this is like negative what you may call 1.5, which is not too bad. So it also goes back to say your sketch is not like usually 100% out of scale. It should guide you in some way, you know. So normally if you see a line passing through the origin, don't now second guess yourself and say, is it really passing through the origin? Yes, it is. Yeah. So those are some of the things when I'm not saying this to like badmouth anyone, but you will be shocked how many times you get questions like that. And it's not to say I don't like getting questions like that. It's because it's me trying to give people data to say, okay, you know what, Ne? I do get asked those kinds of questions. So it's okay to ask them, but this is the answer. So that over time you kind of get your own sense of intuition to say, okay, this it seems like this, so it must be. You get more confident, because even if you maybe don't know and you just do it and the memo tells you otherwise, that's good enough, because you at least worked and did something. When you let me just maybe carry on. I'm off ramping a bit too much. Excuse-moi. What's this now? So we have the midpoint fine. Now the next few questions, as mentioned, they are definitely gonna need us to look at what we have just answered, which is really underrated when it comes to math questions. What's underrated is things like how all questions align. Now, what's said is that everyone knows that all the questions are linked, because everyone will tell you that, wait a minute, I couldn't get this 5 4-mark question because I couldn't get the previous one, because I couldn't get the previous one, blah, blah, blah. It's fine. So now you know, get the easy marks and then use them for the hard ones. You see, it's just knowing. Like for example, here, they're asking us, why is EM parallel to BC? Before we go to the sketch, your question always gives you what you should use to answer it. Just like all these ones, the question asked for t, so we used t, traced, and saw what was useful with regard to where t was. Same here, same here, same here. Now we're here. They're asking about why these are parallel. So instead of us like maybe panicking or whatever, because most people don't like these kinds of questions, instead of panicking, blah, 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 the first thing is, okay, fine, there's certain things about parallel lines. So you use that. There are certain things about parallel lines, so make use of them. The issue is with math, right? People go into math questions. And when I say people, I'm referring to myself. When, whenever math was an issue. There are times when, okay, not times, all the time, the mistake was assuming that in a math exam, you need to figure stuff out based on your own thinking, which is wrong. In a math exam, you figure stuff out based on stuff you've figured before and based on stuff that other people have figured out. That's literally the weirdest thing with school in general, or sometimes with life. People just want to think they know everything. So they'll assume that, okay, fine, a math question, you need to answer it. They don't even assume, they just try to do their own thing, which is like, why you gotta do that? It's a test. There are past papers. There are past papers with memos. All the answers are there. You might as well just use that and do it. You don't need to reinvent the wheel. So what I'm trying to say is, firstly, it's a question. It's talking about parallel lines. So you want to think in your mind, your brain will already be thinking of different things about parallel lines, depending on how many questions you've gone through, right? So we know things like parallel lines. If two gradients are equal, the lines are parallel. If you have things like fun, you have parallel lines. If you have we cannot list everything now because we kind of need to use our sketch to help us specifically for this question, but we will have some kind of an idea of what entails a parallel line. A parallel line comes with certain laws that must be present, you see. So that's what you use. You don't now use your own thinking or try to think I'm going to be Einstein, and no, it's not going to work. So for example, where is em? Em is specifically a point. It's one line from one point to the other. And the funny thing is, as you can see, M, we worked it out. So clearly, if someone had no M, you're done. And E is something worked out. If someone has no E, you're also done. You see. Let's see. E is what? We got it as, I think it was negative. What was E? Was it -4? Yeah, it was -4, which is kind of accurate because the X value here is a -5. So just a bit before it should be a -4. So that's fine. We had to get it. We had to get it. Everything is just piling on each other. It's like, it's okay. Now they're saying we should prove that this line is parallel to the other one, which is BC. Now, the fortunate thing is when you're going to prove something, use assumptions to what you call, when I say use assumptions, what I mean is, no. Let me put it this way. I shouldn't have used that word. When you're going to prove something, already see what you're trying to prove as though it is true, because it is true. They would not ask you to prove that these are parallel if they are not parallel. Them asking you to prove that these are parallel, what you want to do is you want to go to your sketch and you want to know that these are parallel. That's the first thing. Might as well even put all this. So now your brain knows, okay, these are parallel. So what you now need to then do is in this sketch, because these lines are parallel, you want to now go and put in things in the sketch that need to be true or that will be true based on the fact that these are parallel lines. So you don't need to do anything crazy. As we said here, do the simple things. Okay, wait a minute. If these are parallel, then they should have the same gradient. That's one ammunition to use. Secondly, if these are parallel, you know things like, okay, this angle is equal to that one because they're corresponding angles. You know things like this one is equal to this one, they're corresponding angles. Whether it's useful or not, doesn't matter. Your brain needs to think of those things so that over time you become more confident with these kinds of questions, because you don't want to look too far. The one mistake I always used to make is firstly looking too far, but then secondly, unfortunately, not having anywhere to look from. And not having anywhere to look from is Again, things like not having the experience, not having past papers to refer to mentally, because your brain has stored many things that you can't even remember them until you're put in a scenario where you're forced to remember them. You see, I'll repeat, your brain has things stored in it that you cannot at will recall. You need to put yourself in a situation where your brain recalls those things for you, because unfortunately our conscious mind is not that smart, you see. So it's like if someone, let's say, gets into a fight, right? And I don't know, someone, let's say, sucker punches them in a certain way, one way or the other, if you get in another fight, the first thing your brain is going to remember is that time when you're sucker punched. But then if you're just going about your life, normal day things, that's not the thing your brain is preoccupied with. Your brain needs a scenario for it to go into its memory to unlock whatever you need in the present moment. You see, that's again why past papers are important, because in as much as we may think that, okay, fine, we're going to go through this question, but then how am I going to remember it in the future? You're only going to remember it in the future if you put yourself in another situation to remember it. And the only way to do it is to just keep doing it. You see, it's not all going to be 100% the same, but then your brain is, I mean, the subconscious mind is more smarter than us at putting pieces together, you see. So already here, even though we're blabbing and all that, we already saw what the answer is. We just need parallel lines. We just need to prove that these lines have the same gradient. It was in the water, done, finished. We just knew. Yeah, 4 marks. You see, because now we have a coordinate. A coordinate is just a matter of getting a gradient, you see. Gradient number 1, check. Coordinate, gradient number 2, which is how, again, all these questions have now all come together. The first one, ask for T, it's a coordinate, we needed it. It's a coordinate, we needed it. E, it's a coordinate, we needed it. M is a coordinate, we needed it. Sometimes it even gets, I know it sounds weird for me to say, but I'm not the one writing. So it almost gets a bit, I don't know, it just shows how some things are just cheap. Like, so that's what this is all about. It's not like someone trying to like plot and scheme against you to like get bad marks, which the reason why I say a lot of the things I say, it's honestly because that's usually how I used to think. I used to think with maths, they're just trying to trick you. They're just trying to finesse you, but they're not, because it's a test anyways. If they're gonna tell you that on the day of your license test, you're gonna do parallel parking, and you rock up there and you're not doing parallel parking, it's like, what? You're just gonna walk out and go, because it's like, it doesn't make any sense. Yeah, so the things you're going to be tested on, don't assume that they're trying to finesse you into asking something different. It's usually as straightforward as it actually is. That's why you have these, I'm not gonna call them weird, but I think they are. That's why you have these people that get 100% of their math papers. They're not weird in a bad way, but they have just like played the game so well that they just, it's just so possible, especially with things like math, because it's such a game that's like, it is what it is. So let me just move on. But I think we need, clearly what we don't need here is, we already know what to do, so we don't necessarily need to do it, because all that's going to happen is in the follow-up questions, we just need to make sure we use the fact that these are parallel to help us if it's going to be useful, you see. So that deals with 3.4. 4 marks in the bag. We didn't like sweat, you see. It's just like, you can see, it's not about the sweating, it's about using the question to answer itself, more or less, you see. So it's the same idea with things like 3.6. And it all goes back to what I mentioned in the beginning here. This is analytical geometry. In a past paper, this would be like maybe 40 marks. And let's see how accurate that is, close to 40. So if you look at this specific past paper, let's see, it's a 2018 prelim paper. Remember, prelims, the whole syllabus is the same anyways. The total is the same, 100% everything. It's out of 21, right? The first question. The next one is out of 20. That's actually 41. So you can see here, 41 marks out of 150 is analytical. And we said that things like the analytical geometry course, it's 3 to 4 hours, because analytical geometry, it's like the small guy, figuratively, maybe not literally, but it's like maybe the really tall guy that really has jack. or the really buff guy that is actually like a girl at the core, so they can't do anything anyways.
Yeah.
That's why this is not gonna need a lot of hours. But with something like trigonometry, let's see here. Let's just tell you the marks. Trigonometry 11, 7, that's 18, right? And then there's another question here, 22. So it's 18 plus 22. 18, 22, total 40. This is 40, this is 40. But then trigonometry is slightly at a higher level in terms of what you need to have in your tool shed. So that's why things like the trigonometry course will be more like 8 to 9 hours now, but it's still the same marks. So the point with going through full papers is that you will get that way of thinking where you'll go through papers and you'll notice, wait a minute, I'm getting 40 marks here for not doing a lot of work. But then I'm just going to get that same 40 for doing a ton more work. So a person would then realize that, wait a minute, what the best thing they can do for themselves is to not spend the same amount of time on trigonometry and analytical. It's not going to help you, because if you split this half, you may end up getting this 40, but then here you end up getting a 10. It doesn't help you. All the hard work here, it gets drained here. It's almost like when a person has marks on a report. Good, bad one. Good, bad one. The bad ones affect everyone. You don't get high marks because you have a lot of high marks. Oh, no. You don't get low marks because you have a lot of high marks. No, you get low marks because you have some low marks anyway. Whether it's 90s, 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 if there's a 10 here, the 10 is going to bring everything down. You see?
Yeah.
So in an exam, when you have not, let's say, over time been really going through full papers all the time, you're going to find yourself not knowing how to divide your time. And then now your marks come back like this, because you spent the 5 or 8, 10 hours here and the same 10 to 8 hours here. But then this one you got your 40, but you really did not need all that time. You just needed not so much. And I hope these kinds of questions that we're going through are almost like highlighting that, because we're really not we're not doing anything special. If you look nicely, all the questions we've used, it's literally all formulas, all of them. No heavy lifting. It's a formula we plug in, and it's really almost like really weird formulas. It's just distance formula, equation of a straight line, midpoint formula. So all those things, we should use them to our advantage, right? Speaking of formulas, 4.6, 3.4, it's a 4-mark question. It's asking for an angle. So firstly, before looking at the sketch, which we obviously will, one thing I can mention is, again, knowing the structure of questions is important, because the moment they ask for an angle, over time, depending on like the amount of questions you would have gone through, blah, 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 over time, what you will know is, okay, wait a minute, they're asking for an angle. So whether you like it or not, you're going to need to think of the tan formula. Whether you use it directly to get your answer, it doesn't matter. In analytical geometry, as long as they're talking about an angle, this has something to do with it 99% of the time. Now, 99% of the time is good enough for you to know how to use this question or formula all the time. You see, it's worth the investment. So us knowing that we're definitely going to make use of this some way, somehow, that's one foot in the door automatically. I mean, like, if you're lucky and you write this down, it's a 4-mark question, you're probably going to get 1 out of the 4, even if you just leave it. So let's see what the question really wants now. Let me even bring this closer down here. For obvious reasons, we need clarity. We need to see what the sketch really is all about. Now, because of all the information we have, I mean, our sketch is just information overload, in a good way, hopefully, or rather in a good way. I mean, like, it is what it is. So they want the angle ABC, right? ABC. Let's see, there's A, there's B, there's C. ABC is here. Now, from my own experiences, anytime an angle was down here, anytime an angle was not here somewhere nicely, it was an instant trigger, instantly, because it's like, but why is it down there? How we're gonna get it all the way down there? So it all boils down to, what do we have and how can we use it, as we have already showcased. It's just like a mini checklist. Now, the funny thing is, sometimes you may even, not sometimes, like be comfortable with making your question paper your own, you know? It goes back to what I was saying in the beginning here, drawing some things there, making sketch, do it. You don't want to be too conservative. Your paper is neat. What? It doesn't matter. It really doesn't matter. You may be shocked, but the exact same way I write, I'm not saying it's pretty, but it's the exact same way I wrote all my exams, all of them, because there's some things that just don't matter. What matters is being comfortable. You don't anything you're gonna need to do. Don't make it too depressing. Like just find a way to just finesse it and not do it dreadfully. So for example, we have a sketch, we have so many things, it's good. They want us to get this angle. So as mentioned, the checklist will go something like this as mentioned. Okay, fine, where is the angle? Because remember, in all these questions, always start with the question, because the question has all the answers. All of these questions, they gave us all the answers, all of them. It's a coordinate, So we made use of what coordinates are. This is an angle. But then apart from us just focusing on the angle, I mean, where is the angle? It's an angle at a specific coordinate. Okay, fine. That's one thing. The angle, the coordinate itself may not be very useful, which is fine, but it's something. Something else. Okay, fine. It's an angle on a point. But then now we can build on us knowing that there's a point. Point B is on two lines. There is line AB, which is definitely useful, as we have seen. It's also on line BC, which is definitely useful for reasons that we may not know. But then the thing is, remember, we mentioned at the beginning, anything they'll give you in the beginning of your question, they are not just giving it just because they want to waste ink. No. If you look nicely, right, this is it's a 6 question section, 3.1 to 3.3. There is nothing after 3.3. I mean, after 3.6, sorry. There is nothing there. And you knowing there's nothing after 6.3, I mean, after 3.6, it's good enough for you to say, okay, wait a minute, there's no questions after this, but then, where's the, wait, there are no questions after 3.6, but then they haven't asked anything about beta, we have never even used it. They haven't asked anything about theta, we haven't even used it. But then they still put them there. They still gave them, angles that are open. There's a reason for that. They didn't mention anything about theta in this whole thing, but they put them there. It's already like, I don't know. It's almost like sometimes when they set some questions, they really cannot withhold anything. They just have to give it to you. So automatically, your brain should go into a gear where it goes in such a way where, okay, fine. In as much as we need this angle, we're gonna use this and we're gonna use this. Period. There's no two ways about it. So firstly, the first thing is, okay, fortunately, all these are both angles of inclination anyways. So we might as well get them. Guaranteed we need them. Yeah, I think you get the idea. Let me not, just be extra now. So what we also know is, okay, fine, it's on a line, but thirdly, what's important about angles, very important, is where or which triangle the angle is in. That's like where the game gets totally flipped on its head, because that's where it ends. It's on a line, it's on a point, blah, 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 but then it's in a triangle. The moment you know it's in a triangle, that's where things like this P comes in that we spoke about right in the here. Angles on a straight line, that's important. We already spoke about fun one or the other, but then now we're here where an exterior angle of a triangle, things like that, they're subtle. They don't just present themselves all the time. Well, they do, but then they're always just in the dark. But then you won't know something is there. Okay, if something is in the dark, right? If you saw it in the light and you switch off the light, it's still there. So the analogy I'm trying to make is, when you're practicing for tests, it's like the lights are on. You're seeing everything. They are telling you what to do. The memo is showing you what to do. They show you that something is there. When you get to a test, they switch off the lights. It doesn't mean those things are gone. So the same way when you're practicing, you notice that, okay, fine, the memo said that the memo used the angles of inclination. In an exam, you're gonna do the exact same thing. You know, you're just gonna use the angles of inclination anyways, because someone showed you that, okay, those are useful. So in our case here, we just need the angles of inclination, right? And this is how we get our angles of inclination. So our angles of inclination, we always use our tan formula as mentioned. So to get theta, we're gonna have the tan theta is equal to the gradient of BC. So we need the gradient of BC now. Let's just put it in our calculator. The gradient is gonna be something like -3 minus 5. And then -3, I think this was, what was that now? Was it a 4? Or what was the x value there? What was the x value of t? 4. Fine, so let's just put a 4 over there. And then you have a -8, -7, 8 over 7. Looks accurate. It's a positive gradient line, so it's okay. It's not too alarming. Now, this is where things get okay. I mean, there's nothing to this portion of the question. But then anytime you need to get an angle of inclination, the one thing we all need to remember is that whether you're dealing with a negative angle like gradient or not, always get a reference angle to help you then figure out what each side is. What I mean is, whatever you do here, you're always gonna either get an obtuse angle or an acute angle as your answer. Or I think it was an acute angle or something. But then what I mean is, if they asked for, let's say, this side here, you would still do exactly all that we're doing, but then your calculator will always would have given you something like this side. And then after getting this side, you would then need to remove it from 180. It's just a way to say, in this case, the name reference angle is more like literal. You're just gonna get a reference angle and you're gonna use it as a mini guideline to say, okay, is this my answer, or I need to remove 180 or something. So a reference angle here would just be like shift 10, 8 over 7, right? So in our calculator, shift 10, 8 over 7, this is like 48.81. So without even worrying about it, our reference angle is definitely our angle for theta, because our theta is the acute angle here. So we'll take it. But then if we had to get, let's say, this side here, we would not do anything different. We would just still get our reference angle, but then we would then now remove it from 180 because we want the other side, you see.
Yes.
Same thing, you just have to pick which side you want, but you use the same formula, right? So that's that for the theta. So you can see we haven't even touched on the angle they have asked, but we're just doing the blunt things. They told us this is there, they told us this is there. Whether they asked for this or not, this is important because they didn't ask us to use it directly. But then because from, let's say, having to have gone through previous questions, blah, 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 you would already know why they have labeled this and labeled this, and they didn't label anything else. Anything they didn't label here is because it's useless. They're not gonna put a random alpha here just because, or a random beta here just because. No, 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 no. Anything they put on the sketch, you're gonna use it, you see. So let's get this angle here. The gradient of AB is -3, you see. So same thing, so shift 10, what is this angle here? Beta is equal to -3. And we said always use the positive number. So here you're gonna reference angle, you're gonna get a reference angle, you're gonna put the shift 10, 3. Now in our calculator, let's see what we're getting here. Shift 10, 3. If you look, we're getting 71.56, which is why always call it a reference angle first, because now you can just refer to it to get what you're looking for. What we are looking for is not an acute angle. We are looking for an obtuse angle. So the 71 point whatever that we got is this side here. It doesn't mean what we did was wrong. No, 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 no. It just gave us this. So now we can say, okay, fine. Our actual beta is now 180 degrees minus that angle that's just helping us, you see. So this is like 180 minus the answer, which is 108.43, which is perfect. You know, it then goes back to these small things, angles on a straight line, always make use of those small things. Things like vertical opposites, those things, it's all literally almost in this question, because that's where different methods really can shine in these kinds of questions. Because now that we have this angle, now we have this angle, it's information overload to the extent that you can do whatever you want here. You know that, okay, fine, this is theta, right? Theta, we got it to be 48.81. So you can label this 48.81, fine, but then it's gonna be useful to you if you maybe label this 48.81 as well, because these are vertical opposites. Remember, we're working with a triangle here. In this triangle, we have this angle. So, I mean, they're asking for this angle, but our advantage now is that we have this angle as well. Fine. Whether that's going to be useful, it definitely is. But whether we're going to choose to use it, it doesn't matter. We'll see. And then here, since we now have this angle, I mean, like, we also technically have this angle, whether one way or the other. This is still also just the 71.57. So now it's like we have so many options. I'm just labeling this to show how many options we have. But then, apart from it, we have this angle now, and we need this. So we can easily say 180 minus the other two, get an answer, and be done. I mean, your memo would also maybe show you other things, like maybe things like how the angle out here, right? That's beta. Beta is an exterior angle of our triangle. There's beta over there. The angle they're asking us is this one here, right? But then we have the 48.81, and we have the 108.43. It's all the same. Whether we want to say, okay, fine, 108.43 is equal to beta plus the 48.81, it doesn't matter. We'll still get the same answer as having to have put all this, removed it from 180. It's all going to give us the same answer. But then the memo would maybe show us all those things to a point where we'll just know it's fine. You have multiple options, yes, it really doesn't matter. You just use whichever one comes to mind first, or whichever one is easier, and then you just move on. Cool. Does that make sense?
It does.
Nice.